For question 1, diagram 1 shows the orbits of two objects. Select words from the box to add 3 missing labeled words to diagram 1. So at the center we have star, but the closest celestial object rotating around the star, which is planet. And in elliptical path we have comet. In section B, diagram 2 shows the moon orbiting the earth. Draw an arrow on the diagram 2 to show the gravitational force acting on the moon due to earth. So the gravitational or the mutual attraction force between the moon and earth, so you have to draw an arrow from the moon toward the earth. It's kind of a centripetal force. So please use the ruler and pencil and you draw an arrow which is toward the center. This is the FG, the gravitational force between the moon and earth. For section C, give a name for a large collection of billions of a star. So the correct answer, the group of stars, you can call it galaxy or galaxies. In question 2, the photograph shows a child bouncing on a trampoline. The box lists some types of energy: chemical, elastic, gravitational, kinetic, thermal. The passage describes the process of bouncing on the trampoline. Use words from the box to complete the passage. Each word may be used once, more than once, or not at all. As the child falls, his blank energy is mostly transferred to blank energy. When the child hits the trampoline, his energy is transferred to blank energy. Let's break this down step by step. As the child, they are moving faster, is moving faster and faster. The movement means he has kinetic energy. Where did that energy come from? When he was at the top of the bounce, before he started falling, he had gravitational potential energy because of his height. There is a small height here above the trampoline. So as the child falls, so his gravitational energy, and this is the first blank, gravitational energy, is being converted or mostly transferred to kinetic energy. Why? Because he's losing height and gaining speed while falling downward. The moment of impact, when the child hits the trampoline, his kinetic energy, and this is the third blank, is transferred to the trampoline itself. And my question is, what kind of energy does the trampoline store? So the answer, well, it's stretching and deforming the trampoline itself. So it's elastic potential energy. And this elastic already as a potential energy stored inside, think of it like a compressed spring. For section B, trampolines have springs that stretch and compress, and the student investigates a spring to see if it obeys Hooke's law. She measures the extension of a spring for a range of different stretching forces. Describe how the student could measure the extension of the spring. I took a screenshot from the internet, this one for the trampoline, and these are the springs. So let me break it down each marking point. First, we try to measure an initial length. And what length exactly? This one is the length of the spring before adding any weights. You might also call this as original length or the distance from the bottom of the spring. So I'm going to measure from this fixed end to the end of the spring, or to the free end of the spring, and I have to use my ruler, and it's preferable to start measuring from 0. So for my initial length of the spring with no load or weights. Point 2, we are going to measure an extended length of the spring with load or weights. So for mark point 3, I would say extension equals to the extended length minus original length. I told my students, if the extension is x, so the extended length is L minus L0 when there is no applied force or load. One of the important or the most important keywords here, I'm using the word measure. I didn't say calculate, okay? Because I have to use a ruler. So I already get the 3 marks, but if I want to make sure that I'm convincing the examiner I deserve full mark in this question. So here, I'm going to use a ruler, and it's a simple, but mentioning it is really important. If you're feeling fancy, you could say using caliper, which is even more precise. This is the Werner caliper, which makes you more fancy and give you a precise answer. So for marking point 4, use of a ruler to measure all length. For marking point 5, this is where you can really shine. It's a kind of detail to improve the quality of measurements taken. The mark scheme gives here some great examples. For example, marking the spring with a pen or marker. You can make a mark here, okay, using a pen or marker, at least that you show there is a kind of at the free end, there's a marking point that is going to be like kind of a second reference when the spring is stretching. Or take measurements from the same points on each spring. Each time use a fiducial marker. It's a kind of fancy for a clear mark on the spring to help you measure consistency, but my students, so they might not get what is the fiducial mark. The right side here, there is a ruler and a spring and weight, clamp stand, and there is a pointer here, which is the fiducial marker. I can add this fiducial marker, quite light, is not heavy, and this one, it's to improve the accuracy and precision of the length measurements. By the end of this section, I already achieved 3 out of 3. Double I, the student finds that the spring does obey Hooke's law. Sketch a graph of her results on the axes. On the y-axis, we have extension, the x-axis is force. So the relation between force, or the force, is directly proportional to the extension. Draw a straight line from the origin. Do not draw any curved line because the examiner said it does obey Hooke's law, the key word. So you will get 2 marks. 1 mark because you already started from 0, from the origin, and you have a positive gradient, so it's a straight line. And remember the formula, which is F equals kx, so F directly proportional to x, which is displacement. Question 3, the photograph shows an electrical appliance called a toaster. In part A, the toaster has a power 1800 watt when operating at voltage 230 volt. State the equation linking power current, and voltage. The correct answer is power equals electric current times voltage. Okay, this one I get 1 mark. Shall I write symbols? Yes. Power equals current is I, voltage is V. So this is for section AI. For section 2I, show that this is an effective and important keyword. The current in the toaster is about 8 ampere. How can I get this? I equals P divided by V, or power equals I times V. Okay, let me use P equal I times V. 1800 equals the value of the electric current, which is unknown, times the voltage at 230. So current, which is I, equals, you have to say 1800 divided by 230. The correct answer for this question is 7.826, which is approximately 8 ampere. Show the examiner this value. Show the examiner because he was asking for show that. Show that in physics we need 2 to 3 significant figures. Triple I, which fuse rating would be suitable for the toaster and definitely is not going to be any value less than 8 ampere. So the correct answer is 13 ampere, which is D. Section B, the toaster uses mains electricity. Mains electricity provides alternating current. Describe the difference between alternating current AC and DC. Okay, I know the DC from the battery or the electric cell. So the DC is the flow of charges, for example, from the positive terminal to the negative terminal. And this one is the definition of the conventional current. So it means that the flow of charges in one direction. So I get 1 mark for the DC. But for the AC, what does it mean? Here is a kind of a fluctuation and we change in the polarity. So I would say the flow of charges in one direction, and now it's still a DC, but I have to add then the other direction. So now I show the examiner the difference between DC and AC. Okay, section or the last section state a source of direct current. The famous source is battery or the electric cell. Question 4. A student has a small piece of steel. Describe an experiment that he could do. Find the density of a steel. You may draw a diagram to help your answer. I already give you the diagram, so you just copy this diagram in your exercise or the exam paper. So the diagram has irregular solid objects. We place it on the electronic balance and shows us the reading. So the most important here, if you think about the density equals mass divided by volume. I'm dealing with an irregular object. How can I do this experimentally? So first point is I want to measure, so I will go for measure the mass of the steel. I will get 1 mark for this, say by or using here an electron balance. Here I deserve another mark for these 2 points. So I already mentioned I'm going to measure what exactly, which is the mass, and the electronic balance, which is the device. Or fill a measuring cylinder using with enough water. Why? Because I want to submerge the steel. Okay, the point 3, this is really important. I have to measure again. I'm going to highlight this keyword. Measure what? Measure the volume of water And let me say this is V1 into the measuring cylinder. Okay, that point 3. So shall I get 1 mark for this one? Yes, I will get 1 mark for measuring the volume of water. What should I say? The point 4 or the marking point 4 is to use the displacement method to measure the volume of the irregular object, which is the steel. You have to place the steel into the measuring cylinder, and when you place it, please place it gently because you want to measure the volume and avoiding any splashes. So mark point, we're so close to get marking point 4. You have to measure now the final volume of water plus the steel or the object. So let me say this is V2. Now I am so close to get marking point 4. So what is marking point 4 here? So definitely is to measure the volume of the steel using the equation V2, the final volume of object and water, minus V1. Okay, so shall I get 1 mark? Definitely there is 1 mark for this point. Okay, but I did not mention that how can I measure the density? Density is mass divided by volume. So I would say using the following formula, which is D of density of the steel equals M divided by V2 minus V1, which is the difference between the two volume. And the density, by the way, it's measured kilogram per cubic meter. I think I deserve the 5 marks in here for mentioning all of these 5 points. There are some other points for accuracy and showing the precaution in the experiment, like for example, object tied to thread when you place it gently inside the measuring cylinder, awareness of meniscus when you take the reading, look at the eye position, take the reading from the bottom of the curved surface, this one to avoid parallax error, and measuring, which we call it at eye level. Repeat the readings more than once, taking the average. You have to check that the balance itself is starting from 0, so 0 mark. And when you check the pan of the balance itself, it's horizontal surface, there is no inclination or there's not any other pieces of metals for irregular value might affect on your readings. And as I told you, we avoiding splashes, so we have to drop the object gently into the measuring cylinder and measure the mass before the volume, because the object might be wet, and later on you measure the mass with water. So preferable is to measure the mass first of the steel, then you go for the displacement method. So this is the end of this question. We get 5 marks, 5 out of 5.